Hi, this is a video of our submission to the Binance Hackathon. What we managed to do was deploy the Nightfall privacy preserving solution from Ernst& Young onto the BSC testnet. It's quite interesting because what it does is it opens us up to allow enterprises to use the BSC network to do private transactions. First, using Nightfall, and secondly, potentially, if we get an opportunity to expand it, to actually try and get baseline to run on the testnet as well. So we chose to run Nightfall first because we wanted to test to see if the different binaries and the different pre-compiles that are required for Nightfall are actually available on the BSC testnet. So it was very, very successful. With a few tweaks, I managed to get this whole thing working, and this video will demonstrate exactly what was done. We'll just walk through a quick demo of the user interface, and then we'll show what happened on the underlying blockchain as the transactions occurred. All of this happens under zero knowledge using the zkSnarks library and Nightlight and Nightfall from Ernst & Young as well. So what I'll do is I will just hop over to the video. And I'll just walk through what has happened. So we've created three accounts, Alice, Bob, and Charlie, so A, B, and C for short. And we'll just log in the different users. So I'll just start this video now. So you got Alice logging in, and what she's going to do is she's going to mint an EY token. And we'll call it just a Binance Hackathon token. So this is an ERC721. And what she's going to do is she's going to transfer this ERC721 to different people. So the first thing you'll need to do is mint the commitment. And what the minting of the commitment will actually do is to transfer the ownership of the token to the EY Shield contract. So Shield contract allows you to do these private transactions on the public mainnet. Everyone can look at it, but they have no idea what's happening in the background. So we'll do that. Maybe just a quick point. Each of these things that are happening, all these different events, actually takes quite a while to do. My laptop's quite slow, so it does take a bit of time to process each of them. I've actually sped up the video. So when you're running this, you'll see it'll probably take about between maybe 1 minute, 3 minutes, even up to 5 to 10 minutes, depending on what you're doing. And that's just because we're doing a lot of different zero-knowledge cryptographic transactions in the background. And those take a very long time. So you have to have quite a bit of hard drive space, as well as a fair bit of CPU and memory as well. So what's happened is we've minted that token. What are we going to do now? Alice is going to actually transfer that token to Bob. And this is all done in zero knowledge. And I'll show you what's happening in the background. So they do that on the ERC721 token. Once it's done, we can see that it has been transferred. So if I now log out of Alice's account and log into Bob's, we'll actually see Bob now has the ERC721 token. So what Bob will do now is he can actually transfer that token, let's say to Charlie. So he'll do the same thing, and this is done completely in zero knowledge. So at this point in time, anyone looking into this ERC721 token won't be able to see anything. They will only be able to see that some random person has done something, sent some transaction. But the nature of that transaction will be, it will cause the tokens to be transferred in zero knowledge. So what's going to happen next is we'll log into we'll log into Charlie's account, and then Charlie will then actually burn that token. The point of burning that token is to actually redeem it. So Charlie wants to redeem it and send it to himself. I think in this example, we're going to actually send it to Alice. So he'll just choose it. Oh, sorry, Bob. So now Charlie's going to actually transfer that token to Bob. And then by doing that, it now appears onto the mainnet, onto the testnet, with the ownership of the token being now Bob. So as you can see, originally Bob didn't have any token, and now he's got one ERC721 token. He can do whatever he wants with it. He can inspect it. He can see who actually sent it from, etc. All of that. So this part's not done under zero knowledge, and you can see the token ID and the token content URI as well. So this part isn't done under zero knowledge. So if you look at the background, you get the backend, you can actually see that Charlie has burnt this token and sent it to Bob. But where that token has transferred, we can't actually see. So next, maybe what we'll do is we'll log out and we'll create a ops chain token now. ops coin token. So this was an ERC-721. The ERC-20 tokens can also be done in zero knowledge. So what we're trying to demonstrate now is that it is possible not just to do ERC-721, but also ERC-20 on top of the BSC testnet. So not the Robston, not the Ethereum, but BSC. What I found when we were using this BSC testnet is it's a lot faster than Robston. In Robston, it takes about 30 seconds to a minute per transaction. What you're seeing now is it would probably, the transaction is not the thing that takes a long time, it's the calculations. So what we're going to do now is we're going to mint an EY Ops coin. And what that will do is that will create 1,000 tokens and assign it to whoever this person is. I think is Bob. And then what we're going to do now is, oh, sorry, Alice. And so what Alice is going to do now is she's going to take 80 of those tokens and send it into the Shield contract. Once that's been sent into the Shield contract, Alice can now do a whole bunch of transactions in zero knowledge. People looking outside will have no idea what's happening. They don't know who sent what, who received what was even done. They don't know the amount, they don't know the balance, they don't know the transaction details. That's the power of that. The underlying maps is a bit complicated. I advise if anyone's interested just to have a look at the Nightfall repository and read through it. I can try and explain it, but maybe in a different video. So what's happened now is we have actually minted 80 coins. So I've deposited 80 coins and I've given it to the Shield contract. Now what we can do is start doing some pretty fancy stuff. We can batch transfer these ops coin commitments. So I can transfer to multiple parties. And this is actually using something called zkRollups. And it's actually rolling up all of these transactions into one zero knowledge proof and committing that onto the blockchain. So what we're doing is we're going to send 12 to Bob and 34 to Charlie. Once we do that, the system will run for a bit and then it will transfer out. If I now log out and log into Bob, I'll see that Bob now has, out of nowhere, 12 ops coin tokens. If we're looking from the outside, once again, you have no idea who received what. You don't even know that Bob received 12 coins. All you know is someone ran some transaction against the Shield contract. But because of the cryptographic steps that we do, you can actually see the transfer. So we log down into Charlie's account, and we can see he has 34 coins. What we're going to do now is we're going to get Charlie to redeem those coins. So right now, if you're looking into the Shield contract, into the ERC-20 tokens, you won't see anything. You won't see the transfer of 34 and 14, or 34 and 12. You don't see that Charlie owns 34 and Bob owns 12. All you see is a bunch of transactions. So what Charlie's going to do now is he's going to burn those tokens and redeem them. He can burn all 34 of them. He can burn a certain amount. And then he just has to tell who he wants to be the recipient of those tokens. So you just wait a bit. It takes about 10 minutes to do this. Most of it is calculations in the back end, running the zero knowledge circuits through Socrates. And in the end, you will see this guy has 34 tokens. So Bob's now transferred tokens back into himself, and he has 34 ops chain tokens. Now everybody in the world can see he has 34 tokens, and at any point now he can do whatever he wants. So it's actually been burnt into his account. So if we actually look at the back end of this, we can have a look at what's actually happening on the testnet itself. So if you go to the README, which I will publish in Gitcoin, you'll see all this information. You'll see what we did, the YouTube video, which you're watching now. You see Alice's address, Bob's, Charlie's. You see the ERC-721 and ERC-20 contracts. So these are the token contracts. And you also see the Shield contracts. So those are the ones that are shielding all the transactions. Did a bit of analysis as well. So if you open that PDF, you can see all the different transactions and every single step that has been involved. But what I'll do, I will just quickly jump into the different addresses. Sorry. So you see 035 is Alice, CBD is Bob, and 055 is Charlie. So what's happening is you just look at the first, forget about the first one, last 10 transactions, and each of them will have something happening. So what we see is if we look at these different transactions, and the contracts that are involved, you'll see that some of them are ERC-721 contracts. Some of them are the ERC-20 tokens. And you see different transactions that are happening. So that's Bob. That's Alice, Bob, and Charlie. I've got that PDF there to explain in detail each of these transactions. But for the time being, let's actually just look at the smart contracts themselves, because that's where all the interesting things happen. This smart contract is the EY token. So that's the EY token contract. That's the ERC-721. And what you see is, even though we've done a whole bunch of steps where Alice transfers to Bob, Bob transfers to Charlie, Charlie transfers back to Bob and burns the token itself, we only really see 3 transactions. And the only thing that's really happening is Alice doing things. So if we drill into each of these transactions, we actually see that in fact, this was just the minting of the token. So you see it's just creating the token from address 0 to address Alice. And then really the next transaction that happened was Alice saying, hey, oops, sorry. And then next one is Alice saying, hey, shield contract, I am now going to approve you to actually do whatever you want to it. So now the shield contract has the permission to manage the funds for Alice. And what the shield contract does is it'll take that token, it'll run a whole bunch of zero knowledge commitments and verifiers, provers, etc. And then it'll move these tokens between different people within the network, all under zero knowledge. But you won't be able to see anything that happens. In the end, if you look at the internal transactions itself, we actually do see the very final transaction happen. And if you look there, what actually happened was, it was this one. It got transferred from the shield contract itself to CBD, blah, blah, blah. And CBD just happens to be Bob. So this is the very last one where the shield contract actually transfers the token to Bob. And that's also done under zero knowledge. No, actually, no, that's not done under zero knowledge. That's done by Charlie right at the end. So Charlie somehow has managed to burn that token and send it to Bob. Now, Charlie had never been the owner of that token, at least from the from the ERC-721 point of view, but he managed to do that. So if you look at the shield contract itself, so if we just check again, the shield contract starts 765, so that's the 765 shield contract. You see a whole bunch of transactions happening. What Nightfall does is it actually proxies transactions. So whenever Alice wants to do one of those actions, Alice, Bob, or Charlie wants to do one of those actions where they transfer a token, what actually happens is Alice transfers some Ethereum to a random new address that's created on the fly, funds that address, and tells that address to, hey, please run this specific commitment or this specific transaction that will just move that contract, the token, in zero knowledge from me, who is the owner of the token, to the next person who's owning it. And there's a lot of fancy maps behind that, and I do advise, if you do want to learn more about it, do have a look at the Nightfall repo. They do a much better job of explaining it than me. So what you really see is you just see ownership tokens of being transferred between, see that EY token being transferred around, transferred into the shield contract, and about 15 minutes later transferred back out into Bob. So really that's all you see. You don't see who did what. I have no visibility of Alice transferring to Bob. I have no visibility of Bob transferring to Charlie. All I see is Charlie initiated a transfer asking the ERC-721 shield contract to transfer to Bob the token. I don't even know that Charlie owns that token, because if I inspect it, it's not visible at all. Likewise with the ERC-20. Once again, the only thing you see is minting of tokens. Ignore this one. Originally I had Bob mint it, and then I thought, nah, that's not good. I'll just have Alice do it because it looks better. So if you drill in, you actually see, Alice has minted 1,000 tokens, as we had demonstrated earlier. And then what Alice has done now is they've approved the shield contract, which is 8956. Yep, 8956 to actually manage those funds. So manage 80 of those funds, if I'm not correct. Yep, if I'm correct. 50 hexadecimal is 80. So if we jump over to the shield contract itself, a lot more things are happening because we're bouncing between things. But really, it's the same thing. All of these are random addresses. You have no idea who's doing what. It's from, well, first of these few are minted by Alice, but after that, you'll see 8521. So ignore this one. Oh, this is the one that's being minted. I think you can ignore these ones because I was just mucking around before. But you see that 035 has transferred 80 OpsCoin tokens, and really that's all you see. And right now, the last one is this guy 5529 has redeemed 34 tokens. So Charlie's redeemed 34. So when Charlie burnt those 34 tokens, that's all they see. We don't even know where it came from. It just came from the shield contract itself. So somehow the shield contract got this token and then transferred over to Charlie. So that's all on zero knowledge. But really, that the real demonstration which I'm trying to get to is the fact that we've actually done this on the BSC's testnet. So all these things are visible. You can go and drill and have a look. The source code I'll be releasing in my GitHub repository, SPRECT8. So do feel free to download it and have a look. Few challenges I had, and what are the next steps? What are future enhancements we could do? A few of the challenges were, had to store a lot of the private keys inside Web3.js and provider.js. So if you look at the repo, you'll see a bunch of private keys which were randomly generated. Hopefully, it doesn't have any funds. Randomly generated just for this. And the reason we did that was because the BSC tokens themselves, whenever you have a funder token, funder address, and whenever you do those transactions, one of those BSC tokens will be transferred, or BNB tokens will be transferred to the random address so that they can do these transactions on your behalf. So what I want to do is once I've transferred that, I want to be able to redeem those. There's no function at the moment that will return the unspent effort back to the main account. So what tends to happen is you run out of Ethereum or in this case BNB, you run out of BNB quite quickly. So instead of losing those BNB to some random accounts that get lost forever, I figured I'll just control the list of accounts and just manually transfer them back in. Just something simple. There was quite a few things I had to change as well. The funding account is revealed as well, which is not a good thing, obviously, but that's quite easy to fix. If I've deployed a version of fsigner inside here that will manage the private keys. So what you can do is you can just connect fsigner to say a key vault or like Azure Key Vault or HashiCorp vault, and just have that being managed. So you don't actually ever reveal the private keys. You just have the components sign it for you. I also did some updates to some of the internal components. That's why when you start this thing up, you actually have to run a few commands, and it changes the Node.js, the Node modules, because some of them have to be bypassed. There's some I found a few bugs in the code which need to be fixed. But interesting, I'm very pleasantly surprised, right? What happened? Okay. Yeah, very pleasantly surprised by how easy it was to just migrate across. The only challenges we had were around connectivity. Because I don't own the node, we couldn't have the unlocked accounts, etc. So what we had to do really was update a few of the providers. So they were all using WebSocket providers, so we just changed it to HTTP provider for now. And there was only one component called Merkle Tree, which needed the WS, so WebSocket provider, because they were looking for live feedback. One interesting challenge I had was when we were using the WebSocket to connect to the BSC testnet, that would drop that web service connection every minute. So that would just keep dropping those connections and really cause us some challenges. So to fix that, we just kept a keep alive. So every 30 seconds, a time would go off and ask for the latest block. And that seems to have kept that connection open. And then it allowed us to do demonstrations. Because you can imagine some of these transactions takes like 30 minutes plus to go through. And if I drop the connection like 1 minute in, everything kind of just grinds to a halt. So there's no recovery feature. And that's just a problem with Nightfall and libraries that we're using, because it's quite old, the libraries. So they don't have that latest recovery mechanisms, etc. Maybe just a quick touch on the future extensions. What we can do if we want to extend this further is to potentially look at extending this solution into baseline. So if everyone's familiar with the baseline protocol, it's a very interesting protocol that allows people to baseline system of records. So if I have a system of records, say an ERP or a database, or even a Google spreadsheet, I can baseline that with someone else's system of records. So really the biggest challenge in enterprises is keeping everything consistent. Within an enterprise, you have an ERP, and that manages everything for you. But outside of enterprise, when I'm working with multiple of my partners or suppliers, etc., and I want to have a consistent view of data, the easiest way is to set a master versus a secondary, or you can use baseline. And there's a very strong drive from the community to go towards baseline. So one thing you could try and do is get baseline to work on top of BSC testnet. And I think it's quite simple because getting this working on Nightfall, it's just transferring the solution over to baseline, and you start having enterprise transactions working with complete privacy, all the nice zero knowledge rollups, all the different innovations that are happening in the baseline community can seamlessly almost migrate to Binance, the Binance network as well. Pretty powerful, I think. A few other things that I touched on already. Transferring the unused BNB back to the depositing account, using the key store instead of having the private keys hard coded into a public repository, and potentially finding clients who might want to baseline their system records on top of Binance's mainnet. So I'm sure the Binance team will have a few people they can think of. And the last part is just for myself, buy myself a new laptop with the Binance Hackathon winnings, hopefully. Looking at that M1X MacBook Pro that's coming up. Anyway, the repo should be up soon, along with this video, and that's pretty much my submission for the Binance Hackathon. Thanks for your attention.